Aloha. If we haven't met before, my name is Spaceman Steve, and I'm the senior scientist at the James Clerk Maxwell Telescope right here in beautiful Hilo, Hawaii. And folks, this might be the most exciting announcement of the year. There could be life in the clouds of Venus. Now, I know the idea of Venusian extraterrestrials sounds a little wild, but hear me out. Venus is an inhospitable, brutally hot, poisonous, and terrifying planet. In fact, the first successful robotic spacecraft that landed on Venus was called Venera 7 on December 15th in 1970, and it was only able to stay in contact with the Earth for 23 minutes because it was measuring surface temperatures upwards of 450 degrees Celsius and surface pressures the equivalent of swimming down about 900 meters underwater. So, crushy, burny. However, Carl Sagan, the Cosmos guy, proposed back in the 1960s that while it's very hard to imagine life that could withstand the conditions of the surface of Venus, bacterial life could exist high up in the clouds of Venus, where the temperatures and the pressures are a lot nicer. In addition, we know that our sister planet may have sustained liquid water on the surface for upwards of 2 billion years, which now exists in the atmosphere as water vapor. Granted, there's also carbon dioxide, sulfuric acid components, and a lot of UV radiation, but these things might actually be able to give the right type of bacteria food and energy. Theoretically, an organism accustomed to this type of lifestyle could thrive in the clouds of Venus. So enter Dr. Jane Greaves and her amazing team of investigators. Back in 2017, Dr. Greaves used the telescope that I work at, the James Clerk Maxwell Telescope in Hawaii, to search for a rare molecule called phosphine in the atmosphere of Venus. Now, since she's the leader of this research team, and she knows a lot more about phosphine than I do, I'll let her describe it for you.
So I like to think of phosphine as ammonia's evil cousin. So ammonia is a molecule where you've got one nitrogen atom and then you've got 3 hydrogen atoms hanging off it as if on little legs. So if you took the nitrogen atom out and replaced it with a phosphorus atom, then you'd have phosphine. The chemical formula is PH3.
What makes phosphine really exciting, other than being a little bit evil, is that it is called a biomarker. Biomarkers are specific types of molecules that can mark the presence of life on other planets. So, each and every single molecule that exists has a unique fingerprint that it leaves in the light that it absorbs and emits. And the James Clerk Maxwell Telescope has a specialized camera that can observe these unique fingerprints, so we can figure out what the atmospheres of planets and space in general is made of. This process is called spectroscopy. This is what the original detection from the James Clerk Maxwell Telescope looks like. Some of the light that we receive from the warmer clouds low in the atmosphere of Venus get absorbed by the phosphine molecules that exist higher up. And this gives phosphine its chance to leave an impression on that light. What you are seeing here is the amount of light that we received at the telescope at different wavelengths. No other molecule can cause a dip in the light right here except for phosphine. Shout out to our camera called Receiver A, by the way. This was the same camera that was used to help take the very first image of a black hole. After the success of this initial observation of phosphine, Dr. Greaves and her team performed follow-up observations using the world's most powerful telescope array, the Atacama Large Millimeter Array, or ALMA, in Chile. And indeed, the detection was confirmed. Honestly, the team didn't expect to find anything. Here's a co-investigator on the study, Dr. Emily Drawbeck-Maunder, talking about the surprise of this discovery.
For me personally, it was an overwhelming experience to even find phosphine in the atmosphere of Venus. None of us in our team really expected to find anything. We were just hoping to kind of test out the observation and maybe put some sort of upper constraint on how much phosphine might be in the atmosphere of Venus. So it was incredibly unexpected, incredibly overwhelming, and it's a really exciting thing.
This was supposed to be a null result, like, we checked for life on Venus, but we didn't find anything. Next. So just imagine their surprise when they found a biomarker on the planet that is literally the closest to Earth. Wow, okay, so big deal. Some astronomers found a molecule on Venus. Wait, here's where it gets cool. While planets that have a lot of hydrogen in their atmosphere, like the gas giants Jupiter and Saturn, can produce phosphine from natural processes, it turns out this is really hard for rocky planets like Venus or the Earth to do. On Earth, there are only a couple of ways to produce phosphine. The first way is through industrial processes where factories expel phosphine gas. And the second, well, I'll let Dr. Greaves tell you about the second way.
It's also made by microbes, small bacteria for example, and they're the kind of bacteria that thrive where there's no oxygen, so they've got a completely different way of life to much of what we're used to. So you can find that in some circumstances like sewage plants, not the most pleasant thing an astronomer expects to have to understand.
Yeah, somehow my degree in physics never touched on the finer points of sewage microbiology. But the team of researchers that Dr. Greaves assembled has a wealth of experience not only in astronomy and physics, but in chemistry and biology too. And they represent prestigious institutions like Cardiff University, the University of Hawaii, Cambridge, MIT, and many more. This impressive team has done a detailed analysis on all of the processes that could produce phosphine on the planet Venus. How about industry? Well, there are no factories on Venus. We checked. What about Venusian volcanoes? Oh yeah, there are volcanoes on Venus. How about lightning in the atmosphere mixing with all of the acidic clouds? Perhaps minerals blown up from the surface of Venus? Can photochemistry naturally produce phosphine in the atmosphere of Venus? Maybe a bunch of meteorites just delivered the phosphine and it originated somewhere off-world. The team considered all of these ideas and more. But the fact is, if you take all of the phosphine that can be produced by all of these natural sources together, you only get 1/10,000th of the amount that the telescopes saw in the clouds of Venus. Now, in contrast, we know about bacteria on the Earth that can absorb phosphate minerals, add some hydrogen extracted from water, and expel phosphine gas. The ones in the sewage. But that's an important point because these bacteria thrive where there is no oxygen, like in the atmosphere of Venus. Dr. Jane Greaves' team found that in order to create the amount of phosphine observed on Venus, Earth bacteria would only need to work at 10% of their maximum productivity. And while microbes on Venus might be very different from their Earth cousins, this is a really promising start. So where did this life come from and how can it possibly exist in the acidic clouds of Venus?
The idea is that life on Venus probably originated at the surface, if it did originate there, in a way much like on the Earth. But when conditions became very hostile at the surface, that would have taken millions of years. It wasn't overnight. And so small organisms might have been able to start blowing upwards in wind and then adapt slowly to live at higher altitudes, completely free of surface conditions.
Okay, I hear you. Don't start calling the tabloids just yet. Don't unsubscribe. I know that this doesn't mean 100% for sure that we have the first detection of extraterrestrial life. The team of scientists, skeptics by nature, make it clear that while they can rule out many different types of natural processes that could possibly produce this phosphine, claiming that there is life, really life, on Venus is definitely gonna take more work. The high clouds on Venus have temperatures up to a very pleasant 30 degrees Celsius, but they are very acidic, around 90% sulfuric acid, and this poses major problems for microbes to potentially survive there. So what can we do? Now that we have this information, how can we find out for sure whether or not there is life on Venus?
So it may be that the only thing to do is to send a spacecraft that can really sample and see if there are life forms there.
Okay, well, while we wait for a spacecraft to be built, Dr. Greaves and her team are eagerly applying for more telescope time to probe this phosphine detection further and to see if there are any other biomarkers that are present in the atmosphere of Venus. But the future of astrobiology is looking brighter every day. Just take it from my boss, Dr. Jessica Dempsey, as she shows off our camera Receiver A, the camera that made what could be the very first detection of extraterrestrial life.
This instrument has 1 pixel. This detection in JCMT was done with just 5 hours of data. So the wonderful thing is, now the possibilities are endless. We have a new instrument that has replaced this one, which is the Makanui, 4 times as sensitive as this little guy here. So we're going to go back and we're going to plumb the depths and the possibilities of this exciting discovery more. And as this is pointed out, who knows what we're going to find next?
Mahalo nui. Thanks so much for tuning in. Until next time, I'm Spaceman Steve.